In this case, it's given that the area enclosed by the parabolas P1, which is 2y equal to 5x square, and P2, which is x square minus y plus 6 is equal to 0, is equal to the area enclosed by the parabola P1 and the line y equal to alpha x, where alpha is positive. Then alpha cube is equal to dash. You have to fill in the blank. First, I draw the graph of this and this on different coordinate plane. This is y equal to 5/2 x square. Therefore, the graph will be of the type this, and graph of the parabola x square equal to y minus 6 will be having vertex at 0, 6, and it will be also opening upwards, and it will be of the type this. Actually, note that because this can be written as x square equal to 2/5y, hence I can say length of lattice atom in this case is 2/5, and length of lattice atom in this case is 1. That is, because length of lattice atom in this case is 1, hence the parabola will be more wider, this parabola will be less wider, hence they will surely cut each other, and we have to find this area. First we find this point. I will just find the area on right hand side and double it. I will get the area of the whole. Therefore, to find this point, I solve these two equations simultaneously. That is, for x square I write 2/5y here. 2/5y equal to y minus 6. That is y into 3/5 equal to 6. That is y equal to 10. That is y coordinate of this is 10. Hence x coordinate becomes 2. I just want to find the area in first quadrant, that is the area of this portion, and I will double it. To find this area, it's clear that we'll be integrating 0 to 2 upper curve minus lower curve. Upper curve has the equation y equal to x square plus 6, and lower curve has the equation 5/2 x square, that is minus this is equal to 6x minus 3/2 x cubed by 3, 0 to 2, that is 12 minus 8/2, that is 8. Hence the area of this whole portion will become double of 8, that is 16. And second part of the question is area enclosed by the parabola P1 and the line y equal to alpha x is equal to the previous area. Let us first draw the graph of P1 and y equal to alpha x on same coordinate axis. P1 is this parabola, and y equal to alpha x will be a line passing through origin, and this will become the required area. And for this point, we solve this equation and the equation of parabola simultaneously. That is, I put the value of y equal to alpha x in this. I get 2 into alpha x equal to 5x square, that is 5x equal to 2 alpha, x equal to 2 by 5 alpha. Here I have divided by x, and division by x is allowed to me because for this point the value of x is sure to be non-zero. Hence we have got the x coordinate of this point as 2 by 5 alpha, and y coordinate is not required. And to find the required area, we will be integrating 0 to 2 by 5 alpha, and upper curve minus lower curve means, because for this the value of y is alpha x, hence I will be writing alpha x minus lower curve is y equal to 5 by 2 x square dx equal to alpha x square by 2 minus 5 by 2 x cube by 3 0 to 2 by 5 alpha, that is equal to alpha into 4 alpha square by 2 into 25 minus 5 by 6 2 by 5 alpha whole cube. This is equal to 2 alpha cube by 25 minus 5 by 6 into 8 alpha cube by 125, that is 2 alpha cube by 25 into 1 minus 2 by 3, that is I get 2 alpha cube by 75. And now, because it was given that the two areas are equal, and previously we had calculated that this area is 16, hence we put it equal to 16, that is alpha cube equal to 75 into 8, hence alpha cube equal to 600. Hence answer to this question is 600.